Hi students, in the previous video we have learnt about the postulates of Dalton's atomic theory. Today let's learn about experiments and discovery of subatomic particles inside the atom, that is electrons, protons and neutrons. Before we get into the lesson, let's understand what is anode, cathode and a vacuum pump is. Battery has two sources, positive terminal and negative terminal. Electrode is a metal plate connected to the terminals of a battery. Metal plate which is connected to the positive terminal is called anode, and the metal plate which is connected to the negative terminal is called cathode. A vacuum pump is a device invented by Otto von Guericke. Its main function is to remove gas molecules from a sealed volume and leave a partial vacuum behind. Basically, it is used to pull out air and gases from a sealed or confined space, due to which the space is left out of any gas and air molecules. Let's learn about discharge tube apparatus. Discharge tube is a glass tube about 15 cm long and 3 cm diameter. It is connected to a vacuum pump. Platinum metal electrodes, that is anode and cathode, are fixed to the ends of the glass tube and is connected to the battery. J. Thomson was a British physicist. He conducted several experiments using the discharge tube apparatus to discover one of the fundamental particles of atom. He created a very low pressure of air inside the discharge tube and applied high voltage about 10,000 volts. He observed a greenish glow near the anode of the glass tube. The picture is a representation of J. Thomson's experiment using discharge tube apparatus. The rays are being emitted from the cathode, that is negatively charged metal plate, onto your left, towards anode, that is positively charged metal plate, onto your right. The rays are emitted from cathode to anode in the discharge tube causes the greenish glow. This stream of rays emitted from the cathode are called cathode rays. J. Thomson performed a paddle wheel experiment with the discharge tube apparatus. He performed the same discharge tube experiment by placing a light paddle wheel in the path of the cathode rays. The cathode rays emitted from the cathode to anode in the discharge tube caused the greenish glow, and the paddle wheel in its path started to rotate. So he concluded that cathode rays are a stream of particles. Furthermore, J. Thomson performed another experiment by applying a parallel electric field to the path of the cathode rays in the discharge tube. The cathode rays emitted from cathode to anode in the discharge tube deflected towards the anode, that is the positive terminal of the parallel electric field. He concluded that cathode rays are negatively charged. He named the cathode ray particles as electrons. J. Thomson conducted the same experiment with different gases. The deflection of cathode rays remained the same with the use of different gases in the experiment. Characteristics of electrons as given by J. Thomson. The electrons are negatively charged particles. Electron is lighter than hydrogen atom. Mass of electron is very small when compared to that of an atom. J. Thomson experiment shows that an atom is divisible and it is made up of very small particles. Goldstein was a German physicist. He used a modified type of discharge tube with a perforated cathode, that is negatively charged metal plate with holes. He observed that certain rays travel in a direction opposite to that of cathode rays. He named these rays as anode rays. Goldstein applied an electric field parallel to the path of anode rays. Anode rays are deflected by electrical and magnetic fields. He observed that the path of anode rays deflected towards cathode, that is the negative terminal of the parallel electric field. He concluded that anode rays contain positively charged particles. Goldstein conducted the experiment with different gases. He observed that deflection of anode rays depended on the nature of gases taken inside the tube. He concluded that heavier the gas, lower the deflection of anode rays in the discharge tube. When hydrogen gas is taken inside the discharge tube, the deflection of anode rays are high. The deflection of anode rays are very little when compared to the deflection of the cathode rays because they consist of heavy particles. Characteristics of anode rays as given by Goldstein. Anode rays consist of positively charged particles. Anode rays are deflected by electrical and magnetic fields. Deflection of anode rays is very little as compared to the deflection of cathode rays because they consist of heavy particles. The deflection of anode rays depends on the nature of the gas in the discharge tube. Dalton's postulates proven wrong. Dalton's postulate states that elements are made up of very small indivisible particles called atoms. After the discovery of electron, the first postulate of Dalton had been proven wrong as he discovered the presence of negatively charged particles inside the atom. Goldstein performed an experiment to prove that atom also contains positively charged particles. The atomic models by different scientists that we have learned so far. To summarize, Dalton proposed that elements are made up of indivisible particles called atoms. J. Thomson further discovered the presence of negatively charged particles within the atom with the deflection of cathode rays towards the anode in the discharge tube experiment and named them electrons. Furthermore, Goldstein discovered the presence of positively charged particles inside the atom with the deflection of anode rays towards cathode, that is, negatively charged terminal of the applied parallel electric field.